this episode, we're going to talk about alerting as a design problem, not a button you turn on. Beginners often assume alerts should fire whenever something looks wrong. But if you do that without discipline, you end up with a storm of noise that trains people to ignore alerts or mute them. Good alerting is about turning raw signals into actionable moments, where the right person is notified at the right time with enough context to make a good decision. That requires you to think about thresholds, event signals, notification channels, and how logging supports investigation after the fact. It also requires aggregation patterns so you can reduce duplicate alerts and understand incidents as groups of related symptoms rather than as isolated messages. If you learn to design alerts with intent, you will produce systems that are calmer to operate and easier to troubleshoot, even when things go wrong. The core question you should keep asking is not "Can I alert on this?" but "Should I alert on this, and what will someone do when it triggers?" Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A good alert usually begins with a signal that is meaningful, and that is where thresholds come in. A threshold is a rule that says when a measurement crosses a boundary, you consider it potentially problematic. The simplest example is a resource usage threshold, like a disk reaching a certain utilization level, but thresholds can also be based on rates, ratios, or patterns. The dangerous beginner habit is choosing a threshold because it feels reasonable rather than because it matches real service behavior. If a server routinely uses high memory during normal operation, a low threshold will create constant alerts that mean nothing. If a service can tolerate short spikes, an instantaneous threshold may fire frequently even though users never notice. Good threshold design is grounded in baselines and in user impact. You want thresholds that indicate a meaningful deviation from normal that is likely to matter soon, not thresholds that merely describe a number that makes you uncomfortable. Another key idea is the difference between threshold-based alerts and event-based alerts. Threshold alerts come from metrics collected over time, where you compare a value to a boundary. Event alerts come from discrete occurrences, like a service restart, a failed login burst, or a link down notification. Both are valuable, but they serve different purposes. Threshold alerts are often early warnings about gradual degradation, like rising latency or increasing error rate, while event alerts are often immediate signals of a state change. The mistake is treating events as automatically urgent. Many events are normal, like a scheduled restart, and alerting on them without context creates noise. The more mature approach is to decide which events represent unexpected, user-impacting changes and which are informational. In other words, events are raw facts, and alerting is the decision about which facts deserve interruption. Notifications are where alerting touches humans, so notification design matters as much as signal design. A notification is not just an alert message. It is an interruption that takes attention away from other work. If you interrupt people too often, they stop trusting the system. If you interrupt the wrong people, the alert bounces around while the real issue grows. Good notification design considers severity and routing. Some alerts belong in a dashboard for awareness, some belong in an email summary, and some belong in an urgent channel that wakes someone up. The channel should match the urgency, and the urgency should be tied to user impact and time sensitivity. A beginner-friendly rule is that urgent notifications should be rare, because the moment everything is urgent is the moment nothing is. A well-run environment treats interruptions as expensive and designs alerts to spend them wisely. This is also where logging fits in, because alerts are about detection and response, and logs are about explanation and proof. When an alert fires, the operator needs context: what changed, what errors are happening, what systems are affected, and what the timeline looks like. Good logging provides that context, but only if it is structured and accessible. If logs are scattered, inconsistent, or missing key identifiers, then alerts become frustrating because they tell you something is wrong, but not why. A practical approach is to treat logs as the narrative layer that sits beneath metrics and events. Metrics tell you how the system is behaving, events tell you what happened, and logs tell you why it might be happening and what details are present. In ops work, It is common to start from an alert, then use logs to confirm scope and identify root cause candidates. If your logging is weak, your alerting will feel weak too, because the response process becomes guesswork. Aggregation patterns are how you prevent your alerting system from turning one incident into 100 interruptions. Real incidents often produce many symptoms. One failing database can cause multiple services to error, which can trigger many alerts across different components. If your system notifies on every symptom independently, you will overwhelm responders and make it harder to see the central cause. Aggregation is the practice of grouping related signals so you can surface the incident as one coherent event with supporting details. One pattern is deduplication, where identical alerts are combined so repeated signals do not create repeated notifications. Another pattern is grouping by shared attributes, like grouping alerts by service, host, or dependency. Yet another pattern is correlation, where the monitoring system recognizes that multiple alerts are likely part of the same underlying issue and presents them together. The goal is not to hide problems, but to make the human experience manageable so responders can focus on diagnosis rather than on triage of message volume. A closely related concept is flapping, which is when a signal bounces above and below a threshold repeatedly. Flapping creates noisy alert patterns and erodes trust quickly, because responders see alerts firing and clearing without clear action to take. Flapping often happens when thresholds are set too close to normal variation or when there is no smoothing over time. A healthy alert design often includes ideas like requiring a condition to persist for a certain period before alerting, or using rolling averages to reduce sensitivity to momentary spikes. The intention is not to delay detection of real problems, but to avoid interrupting humans for noise. If a service has brief, harmless spikes, you want to observe them and perhaps visualize them, but not necessarily alert on them. On the other hand, if spikes correspond to user impact, then you might alert, but you would still want to avoid rapid on-off alert cycles. Flapping control is a core part of what makes alerting feel professional. Another design question is what information should be inside an alert message. A weak alert says CPU high and forces the responder to hunt for details. A strong alert includes enough context to make the first few decisions quickly, such as what system or service is affected, what metric crossed what boundary, over what time window, and what the recent trend looks like. It can also include links or references to where to investigate, but even without those, the alert should tell a coherent story. Good alerts also avoid vague language. Instead of saying performance issue, it should say which indicator is out of bounds and what it means. The aim is to reduce the time from notification to useful action because during incidents, time is lost not only in fixing problems, but also in figuring out what the problem actually is. When alert messages are consistent and informative, responders build trust and develop faster intuition. There is also an important concept of tiering, which is about having multiple levels of signal for the same underlying risk. For example, you might have a warning level that indicates a trend is becoming risky and a critical level that indicates user impact is likely or already happening. The warning may go to a less interruptive channel, while the critical triggers urgent notification. This tiering helps you respond earlier without waking people up constantly. It also allows for better planning because warnings can lead to proactive work during business hours, while critical alerts indicate the need for immediate response. A beginner mistake is to treat every threshold crossing as critical, but a more mature approach acknowledges that systems degrade gradually and that humans have different response modes. Tiering also supports better post-incident review because you can ask whether warnings fired appropriately and whether responders had enough time to act before the critical threshold was reached. Events and logs also help with alerting patterns that rely on change detection rather than absolute thresholds. Some problems are about transitions, such as a service that restarts repeatedly or an authentication system that suddenly sees a burst of failures. These may not be well represented by a single metric threshold at a single moment. In those cases, you can alert on patterns, such as a rate of certain events. The risk is again noise, because systems generate lots of events, and many patterns are normal. The design challenge is to define what pattern indicates abnormal behavior in a way that is stable. This is where baselines and context matter. If a system normally restarts once after updates, that is not interesting but repeated restarts might be. Good alerting design is therefore both statistical and contextual. It uses numbers, but it also respects expected behavior for that environment. To close, alerting design is about transforming raw system signals into human-friendly, actionable information. Thresholds are useful when they are based on baselines and user impact rather than guesswork, and events are useful when you choose which state changes truly merit interruption. Notifications should match severity and route to the right people, because attention is costly. Logging is the foundation for investigation, turning an alert from a mystery into a diagnosable situation. Aggregation patterns reduce alert storms by grouping related symptoms so responders can focus on the incident rather than on the message flood. When these pieces work together, alerting becomes a calm, trusted system that helps you detect and respond effectively without creating fatigue. That is what healthy alerting means. Not silence, not constant noise, but a balanced signal that interrupts you only when there is something meaningful to do.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.